microservices because that kind of makes them more marketable. In today's webinar, we will discover how leading companies like Netflix, Spotify, eBay, and Amazon have achieved success using microservices. Uh, to help us understand this interesting topic, we have Jennifer Rife. Jennifer is the developer relations engineer at Neo4j. She's a widely followed conference speaker, blogger, an avid developer, and problem solver. She has worked with large enterprises to organize and make sense of widespread data sets and build high performance systems. Jennifer loves learning new technologies and launching new products. She lives in California. She loves classical music and horses. And she is very active on social media. Her Twitter handle, JMH Rife, REIF, is very popular with developers. So I encourage you to follow her on Twitter. And she also has a website, jmhreif.com, where she has interesting blogs on topics that could be interest to every Java programmer. This is the second webinar she is doing with Starof. The previous one was well received. It was on Neo4j. Jennifer, welcome back to Starof. Happy to have you join us today. Typically, the structure of the session is, we have 60 minutes. Like I said, if we have some time at the end, we could do Q&A. If not, we will skip that, take the full hour, and people could reach out to you on social media if they have any questions. So with that, I turn it over to you. So let's begin.
All right, perfect. So I'm going to share my screen here. Okay. All right. So today's session, we are going to talk about microservices. I'll also talk a little bit about some other options or blends of architectures as well. But we're going to focus in on microservices. And quite a bit of today's session is going to be live coding. So you're going to see all of this in action. We're going to start from kind of a basic ground up approach and start building intro microservices and kind of work our way up to something a little bit more complex than that by the end. So again, my name is Jennifer Rife. My contact information is there in the lower left-hand corner of the slide. However, I've also got it at the end and a couple other slides in between. But if you think of something after the fact, don't hesitate to reach out to me digitally or through social media or however you're most comfortable. I'm happy to talk tech, Neo4j questions and answer what I can after the session if you think of something down the road. So a little bit of background on me. I am a developer and advocate with Neo4j. I'm actually based out of the central US, so it's not quite as early as what Shasi thought it might be for me, but yeah, I like learning technology. And so then I like to share what I've learned with others, whether that's through writing content, so blog posts or articles or short form types of things, or speaking at events virtually or in person, such as this one. I enjoy doing all of that and just sharing what I've learned and learning from other developers as well. All right, so I would be remiss to talk about microservices if I didn't first talk about the alternatives or kind of the precursor to microservices. Most applications started out as what we call monoliths now. This is where a lot of your functionality is built into a single application. So all of your features, maybe different components, things from different business areas, all built into a single bundle, package, jar, however you want to bundle it up. And sometimes that's designed that way intentionally to package everything together like that into a single application. And sometimes they just kind of end up morphing over time. If you've worked in the industry or dealt with projects, tech projects, you've probably seen this happen. It's like, oh, we'll just put something small in our application. We'll deploy it and then later come back. Oh, we want to add this feature. Oh, we want to incorporate this aspect. Oh, this business unit wants something added on to that. And so then you end up with this monstrosity over time. So that happens too. Sometimes it's intentionally designed and other times it just kind of ends up that way. The pros of this type of structure is that you kind of end up with a one and done type of approach. So you typically end up with one large package. You have to deploy it once. You have to thoroughly test that one item. Pushing it up into dev, test, prod, all that kind of stuff is kind of more straightforward because you're dealing with one thing, right? And there's also less communication, interdependencies, and communication between classes or between packages within the application itself. There's a lot less coordination and kind of wiring things up because it's all kind of there together. The downside to a monolith is finding and reusing pieces of code can be really tricky because you're kind of searching through this massive thing. And implementing fixes can be really difficult because you're potentially impacting other parts of the application. This means things like testing, when you make changes, have to be very, very thorough. And you have a lot of dependencies within that same application. So touching one thing could cause problems with other aspects of the project. Consuming resources is very heavy for these types of apps. So when you want to scale up, scale down, you're scaling the entire thing up and down. Now that makes it really easy to scale up the whole thing. It's just one item you have to scale up or down. But on the flip side of that, you're consuming a lot of resources that you may not necessarily need. So let's say your order application needs to accept a ton of orders for around holiday seasons or big sale seasons or something like that. But maybe you don't need to necessarily worry about the shipping aspect of the application for those days. That would be maybe the following week or something, or other aspects, something like a customer service calls or things like that. You may not need to scale those up necessarily, but you're having to scale the whole thing up in order to handle the excess orders. Also, handling failures can be really tricky because if you have a piece of the application that's not working right, you either potentially crash the entire application. If one piece of the app is down, potentially the entire application is down, or you're potentially impacting other parts of the application when you're dealing with those failures in other pieces. So it gets a little tricky. Oh, I did want to mention too, I kind of like to think of monoliths as kind of this big fortress. So the image there on the right-hand side of the slide is of Helm's Deep from Lord of the Rings. If anyone's seen the Lord of the Rings or read the books. So it's this big imposing fortress. So there's a massive battle there in the trilogy series in the literature. And it kind of has this impenetrable fortress type of mode. So people think, oh, you can't breach these walls. It's just so happened there was a tiny little weak point in the wall that ended up getting breached. And all of a sudden, then the bad guys had access to the entire fortress. And so this is another kind of downside to a monolith. Yes, it's very protected and you can put up all kinds of guards and walls and keep it very secure and safe. But if you leave something very, very small out, a tiny access point, then all of a sudden somebody has access to your entire application. So that can be not so good either. But I kind of like to think of a monolith kind of in this structure, big, imposing, hopefully pretty safe and secure, but not necessarily foolproof. On the flip side of that, you have microservices. And these are typically small applications. You typically build them with a limited or single aspect, feature, function in mind. And you're only going to communicate between necessary services. So if service A needs to only talk to service C, you're only going to connect to service C. You're not going to mess with B, D, and E, and so on. The good side of this is all of these microservices are going to be very independent. They're going to have a very small footprint because you're creating multiple very small applications, right? Small binary, small packages, however you want to think of it. This makes them very reliable and very scalable. You could spin up excess services or instances for the orders without messing with necessarily some of the other pieces of the application or the system. The downside to this is testing can be really tricky because now you're coordinating all of these services together, communicating between the services. You're now having to wire up each individual service to each other individual service potentially. And this is going to add additional layers, additional operations. So things like monitoring, testing, handling failures is going to be different from monoliths, but no less tricky probably, because now you're dealing with all these individual pieces you're having to coordinate and work and plug and play. So on. So I like to think of these more as battle units. So the image on the right-hand side there is the different battles that popped up throughout the campaign for Middle Earth in the Lord of the Rings series. So different kind of small battles that occurred throughout the series. And you can see very movable, very small units that just kind of popped up, and you win so many battles and you eventually win the war, right? Or that's the goal. So you can kind of think of it less fortress imposing one location. You just kind of have these pop-up battle stations that can attack and move wherever they need to at this point. So that's kind of the mentality of microservices. Just a note, neither solution is going to be a silver bullet. So it really depends in the company or on the project that you're dealing with, which solution is going to be the better option. And actually, there's kind of blends or hybrids of these solutions. You'll hear potentially terms like macro services or mini services, or kind of a hybrid microservices monolith solution, which kind of cross-pollinate some of this stuff. Simplicity and complexity are going to exist no matter what kind of blend or monolith versus microservices you choose. I will make a note here that different people will classify microservices, a quote, true microservice system, with varying definitions. So whether you're dealing with certain scopes of functionality in your microservices, if you have asynchronous versus synchronous communication, the level of automation you have in your microservices system, different people will say, oh, that's not a true microservices system. And others will say that is a true microservices system. So it really depends on who you're talking to, how they're going to define and how strict they are about defining a true microservices system. And then, of course, like I said, you have all these hybrids, things like macro services and mini services and hybrid and blends of monolith versus microservices that are kind of these in-between levels as well, that you may not have to go all the way to the end of true microservices, but you may not have to go all the way to the other side of true monolith either. So again, it's going to kind of depend on the project and on the company, and kind of the developer's decisions there too. Okay, so we're going to write some services, and we're going to already dive into some demo stuff. But just to kind of start, here's what we're going to be building throughout the session. So we're going to start with two services. We're going to call one a backend and one a front end. And these two services are going to communicate via reactive REST, if you will, reactive HTTP communication. And we're just going to toss a string back and forth. So the backend service is going to be basically an API. It's going to provide a string. The front end service is going to grab that string and provide it up to a potential client, right? So this is at the base level. This is what microservices is doing. You have two services, two applications that are talking to one another. Now, again, this is not a quote true microservices system, but this is our base level. This is where we're going to start. And then we'll kind of work our way through with a couple of different steps. We'll add a Neo4j database onto the back of that. And that is going to have a Goodreads data set of book reviews loaded onto it. And it's going to be running in the Neo4j Aura DB, which is our database as a service. So there's a free tier level. Anyone can spin up and create their own Aura DB free tier instance. And that's what I've done here, just a free instance that I've loaded Goodreads data onto. So I'll have links for that at the end if anybody's interested in spinning up their own database. But we've got that. And then we're going to have our backend service. And that's going to reach out to a config service. And the config service is going to provide database access credentials to the backend service, which then the backend service is going to take and go out to Neo4j and pull data back, and then provide that data up to the front end service. So we kind of have this kind of loop through a system, a little bit more complexity. Finally, we're going to add a layer of orchestration on top of this. So most microservices systems, especially when you get beyond 2 or 3 services, probably you're adding a lot of coordination, a lot of manual labor to spin up and down and keep these services coordinated. So you'll have tools like Docker Compose, Kubernetes, things like that. They're going to orchestrate and kind of help maintain all of these services in somewhat uniform or grouped fashion. And so we're going to create Docker Compose. That's going to handle our config service, our backend service, and our front end service. The only one you notice that it's not going to handle is the Neo4j instance. And that's because the Neo4j instance is running in its own separate cloud, Neo4j's hosted cloud service, the Aura DB, as I said. So we're not going to let Docker Compose manage that because it's already being managed by Neo4j and we don't have to worry about that. Okay, let's dive into some code. So I'm going to start with just going out to Spring Initializer. We're going to build some Spring Boot applications. And I'm going to work with Maven and Java, the stable release of Spring Boot. And I'm just going to categorize my project so it's all organized on my system anyway. We're going to call this backend, and we can leave the jar Java 17. We're going to add a couple of dependencies here. So Spring Reactive Web. So again, depending on how you classify microservices, we're not going to start necessarily with true microservices communication, asynchronous communication, but we're going to go ahead and set up our services to be that. So we'll have it using the reactive component so that we are able to do complete asynchronous communication later down the road. And then we're also going to add in Lombok. And some people love this, some people hate this, but it's just going to cut down on my boilerplate. So I don't have to write a lot of boilerplate and save some time in today's demo, which is super useful because, as you'll probably find out, we're going to be writing a lot of code. So as it is. All right, we're going to generate this, and I will drop that into my folder here. And I'm going to do the same, basically the exact same application, but I'm just going to call it front end. And we're going to drop that in the same folder as well. So 2 services. And open those up. And I'm going to open these in IntelliJ. And open up on my other window. 1 second. Okay. Move this over here. Oh, and I forgot to change my settings. 1 second. I'm going to size this up so everybody can see this a lot better. And then where is the edit? Oh, here we go. And there we go. Okay. Normally I try to do that before I jump on the presentation, but I forgot to today. Okay, so hopefully that's pretty easily visible to everybody. So I usually like to, while it's kind of spinning up and syncing and everything, just check that everything made it into the POM that I requested from the Spring Initializer. So we got the latest version of Spring Boot, stable version, Java 17. We have our web flux dependency, and we have our Lombok dependency. Those are the 2 we specified. We also get tossed in a starter test dependency and the reactor for reactive testing as well dependency, and then the Maven plugin. So nothing super fancy that Spring's going to add for us, but just kind of gives us the start. Now, since we're dealing with 2 applications and we're spinning these up locally, and they're talking to one another, we could potentially have traffic conflict, right, between one service and the next. So we're going to use different ports for these services to communicate. Now, I like my front end service to use the default 8080 port. So therefore, I'm going to move this back end service to communicate on port 8081. And we'll jump over to front end service and do the same on that side as well for 8080. Now, again, we're starting relatively basic here. We're just communicating with a string message. So all we really need to do is provide a controller class. So we're just going to call this message controller. And this is a REST controller. And we need to have an endpoint. Oops. Request mapping. And we're just going to call this /text, or we could even call it /message if we want to, just to make it match. And then we can provide a method in order to provide some text. So we're going to have a string, and we're just going to call this get message. And then we're going to return hello world. So nothing fancy there. I think I put a double space. Okay. So I think that's everything we need for this one. Let's actually need to slide there we go. Okay. Let's actually run this and see what we get. Okay. Now, if I go over to my browser and spin up I'll go into, whoops, there we go. Localhost port 8081/text. Whoop, that's not good. I missed something. So let me pop back over to IntelliJ. What doesn't it like? Okay, what have I missed? Palm looks good. Port is fine. Let me try this again because I'm not getting any errors in the console. Oh, you know what? Huh. Just realized my endpoint was, I changed my endpoint. Okay. So that's what happens when you do things off the cuff and not necessarily like you practiced. Okay. So we have our message coming back. We've hit our endpoint that we have specified in our application. And now we're seeing that string come back. So our API layer is working. Let's plug this in to our front end service now. So I'm going to head over and open the front end service in IntelliJ. And oh, that didn't work. Come on. There we go. And then bring this over, go full screen with it. Okay, here we go. All right, so same thing here, just checking stable version of Spring Boot, Java 17, our web dependency, reactive web, our Lombok dependency, and then our Spring Boot starter test, our reactive test, and the Maven plugin. Okay, everything good there. The only thing we need to add now is in our application.properties, remember we need to specify the server.port 8080. Now, that was default. You could kind of see that pop up as I was typing it. I wouldn't necessarily have to specify this, but just to make it really clear that we're specifying each individual application is going to talk on different ports. I'm going to go ahead and add that into code, but that is actually the default. Okay, now we need to wire our front end application to talk to our back end application. So the first thing we want to do is we also need a REST controller over here. So we're just going to call this text controller. And this is also a REST controller, and we need a request mapping. We're going to call this a nice, pretty hello for our front end users. So, and then we need to be able to have this controller call the backend service. So in order to do that, we're going to create a bean that's going to use the reactive or the web client library to create a reactive HTTP request, or to be able to reactively use HTTP, if you will. So this is going to allow us to still use HTTP protocol, but do this in a non-blocking fashion. So we're going to do a web client dot create, and we're going to pass in our location for our backend service, which is localhost port 8081, right? Then we need to inject our web client bean here so that we can access it. Just call it client for now. And I need a all-args constructor so that I don't have to write the constructor boilerplate there. And then we need an endpoint in order to reach this. So we're going to be dealing with reactive types, remember, because we're using the web client being there. So we're going to return a string, and we're going to call this get text. And we are going to do a return web client dot, oh, no, sorry, client dot get dot URI. And remember, it's localhost 8081/message, then dot retrieve. We're going to take the body of that HTTP response, turn it into a mono, and that is going to be a type of string.class that we're expecting back. Okay, so we've got our endpoint we're hitting, we're retrieving the HTTP response, we're turning the body of that response into a mono type, which is 0 or 1 in the reactive world. You have either mono or you have flux types. Mono is 0 or 1, flux is 0 to many. And we're expecting the type that comes back in that body to be a string. Okay, so with that, I think I've got everything wired correctly. So let's run this one. Make that happy. And then go over to our browser. And I'll spin this up in a separate separate tab here. Localhost port 8080 / I said hello was the endpoint. Hello world. So you can see that we're getting the exact same thing from our backend service. And now when we ping from the client, the front end service, it's pinging that backend service, which is then providing that text and passing that back on up. So this is working. But again, we haven't really done anything that's kind of true microservices fashion. So let's go ahead and fix that. We'll go back to our backend service. And we're going to wire in a Neo4j database. So in order to do that, we need to add to our POM a dependency, and that is going to use Spring Boot Starter Data Neo4j. And we're going to refresh Maven so that it loads that in. Now, in our application.properties, I'm running this database on the cloud. I would need to kind of wire in the access credentials so that the application can access the database, right? So normally we use the URI, the username, the password, and then because Neo4j supports multiple databases, multi-database, as many DBMSs do, you can actually specify the database name here. Now, again, because I'm running this on the cloud, I don't really want to copy paste my credentials into the application to show everyone. So I have a backup application.properties file that I'm just going to copy into the folder really quickly here and replace. All right, perfect. All right, so now it's in there. I'm not going to showcase it because that would show my credentials. So we're just going to close that file for now, or the folder, and head back and let's wire in Neo4j and the application entities here. So first off, we have book reviews loaded into our data. So we're going to create a data class, and it's going to be called review. And we're going to specify a Lombok annotation that's going to create our getters, setters equals hashcode 2 string, as well as a required args constructor. So that at data annotation is going to do all of that for us. And we also need to specify that this is a node in our database. So you do the same thing in Spring projects if you're using Spring Data with MongoDB or Spring Data with a type of relational database using Spring Data JPA and so on. You would tell Spring that this is a database entity. And when you go to the database, you need to be looking for this type of entity. And then we can start adding in our variables. So we have an ID, and we're going to use the review ID. We also have some other fields on here. So we have a book ID, we have the actual review text, and then we have the date that it was added. And then, was there anything else? Let me think. Yeah, the actual rating. That's right. For the review. So a user will rate a book. And so we want to grab that rating as well. Okay. So that's all we really need to add here starting out. But those are our reviews. Now we need to be able to access those reviews in the database. So I need to create a review repository interface, and that's going to extend the reactive Neo4j repository I could use just a reactive CRUD repository or something more generic, but the Neo4j repository is going to provide a couple of things that are just nice extra features that we can use as well. So we'll just go with that for today. And then we're going to be dealing with types of review, and the ID for those reviews are string. And then we have a ton of reviews in our database. So somewhere close to 100,000, if I remember correctly. And that's a lot. So when I try to demo this and pull it back in the browser, that's a lot of data to try to retrieve and render in the browser. So what I want to do is slim that down just a little bit. And one way you can do that is to write your own methods. So Spring does have some derived finder methods, things that are written implementations out of the box. So things like find one, find all, save, delete, so on. They'll kind of make some assumptions about what you're looking to do and what you're trying to do with the database. So for instance, if you save, you're probably looking to store an entity, right? You're saving something to the database. So it'll kind of derive some of those methods for you. However, if you want to customize them, if you want to write your own, that's absolutely possible. You can do that. And that's what we're going to do here. So we're going to have a flux of reviews that are going to come back because we're going to be looking for a lot of reviews. We're just going to kind of grab a random set, if you will. So I'm going to pick 1,000 that I'm going to pull back. And so we're going to find first 1,000 by. Now, normally, when you would write a method like this, you would provide some sort of criteria after the by. So by name, by title, by author, by release date, so on. But a kind of hack in Spring is if you don't provide a criteria, it'll just grab a random 1,000. So that's what I wanted to do. So that's what I've done here is I haven't provided a criteria. It's just going to grab 1,000 of them for me. Okay. Now I need to wire this into my controller. So instead of /message, we are dealing with a database. So I'm just going to say /neo as the endpoint. It makes a little bit more logic sense. I'm going to call this a review controller because now we're dealing with types of review. I need to inject my repository in here, review repository. I'm just going to call that repo. And then we need to wire this into. We're no longer going to be dealing with a single string coming back. We're going to be looking for a flux of reviews. And we're going to call this get reviews. And we're going to be returning the repo.find first 1,000 by. So all that looks good. And I should be able to rerun the application. And then go out to my web browser and verify that we get 1,000 reviews coming back. Okay. Browser, back to port 8081, but now we're going against database. So I changed that endpoint. And hopefully, of course, now I'm too zoomed in. So let's zoom out just a little bit so we can see a little bit more. And now we get some reviews coming back. And I could scroll all the way down, but we're going to get 1,000 because that's what I specified in the method, right? So we get all of those. That looks good. Now we need to wire our front end service to accept what the backend service is providing, right? So let's jump back over to IntelliJ. We'll switch windows back to our front end application. And we shouldn't need to add anything in the POM or the application.properties because, again, it doesn't care what the backend service is doing. It just needs to connect to that backend service in order to get whatever it's providing, right? So now the one thing that's going to change is we could just return the reviews and read through that or kind of parse through that as a map set of data, but that's not really fun to do. So what's easiest actually is to provide the same data class that we did on the back end in the front end as well. So we want to have Lombok do the getter setters equals hashcode toString. So that way we can access and kind of pull different variables or pieces of that data if we want to, but we don't need to specify the @node annotation because we're not going against the database. Again, this application doesn't care what's happening in the background. So now we just need to specify the variables. So we have a private string review ID. We have a private string, the book ID that review is written for, and the actual review text. Then we have the date time that review was added. And then we have the integer for the rating that was given. Okay. Now, that just helps provide a mapping for the data that's coming from the backend service. All right, now we need to wire this into our controller class. So instead of /hello, let's just call this reviews. Again, kind of aligning that with our data domain. Review controller, that's not going to change. We're no longer dealing with a mono. We're looking at a flux of reviews coming back. And we're going to call this get reviews. And no longer /message. We're going to go against that Neo endpoint. We're no longer dealing with a mono. We're going to be converting the body to flux, and we're going to be expecting a review type to come back. Okay. So that all looks good. Save that. Rerun this application. And I'll just make sure it spins up okay before I head over to the browser. Okay, so far so good. Head over to browser, go over to 8080. Remember, we called this /reviews. And we are getting reviews back. So we get the same data that we got on the backend service. Now the front end service is able to ping that and provide it on up to the client. So this is looking good. We've got our database wired in, and we're kind of one step further along that path. But there's still one more thing we could do. We could add in the Docker Composer, the orchestration tool that's going to group our services together and help us spin them up and spin them down as a unit. So in order for us to do that, there's a couple other things. So we'll head back to IntelliJ, and I'm going to stop this service and then flip back over to our backend service and stop that one as well. First off is, if you remember correctly from the presentation slide that I showed of the architecture we were going to build, we were going to have the backend service reach out to a config service that was going to provide the database credentials for us, so that I wouldn't have to put the database credentials inside the application itself. If you think about it, when you build a microservices system, you're typically, and you're putting it in something like an orchestration tool, you're typically packaging up the application jar, you're dumping it into some sort of virtual container, if you will. So something like Docker, something like Kubernetes pods, and so on. And then you're executing those pods. So imagine if you had database credentials in every application you had, or applications that connected to databases. And let's say your database credentials rotated every 90 days, or maybe they rotate every 30 days, or so on. You're constantly going in, you're updating the application, you're repackaging it, you're redumping it into new containers, you're slowly phasing out your old containers and spinning up new ones with the corrected database credentials. You're doing that every however many days your database credentials expire. So that's really cumbersome. So the way that you can do that is take those application properties out of the application itself, put it in something like a configuration service that's going to handle all that for you. And then you have one place to change those credentials. You change it in the config service, and all of a sudden the application just goes to that config service and pulls whatever the credentials are at the time. So we're going to do that via the Spring Cloud Starter config. And then we need to add a version, make it happy. And we're going to reload Maven. So that should be fine. The other thing is now that we have that config service handling our database credentials, we don't need them in that application.properties. So I actually have another application.properties file. And if anybody's interested what these application.properties files actually look like, I do have them out on my GitHub repository with kind of dummy data, or kind of blanked out data, if you will. And so you guys can check that out. They're out there. I just don't want to showcase that on Zoom. So, and I'll show this one to you in just a second, because this one doesn't have any database credentials because the config service is handling it. Okay, so that should be in there. Now I should be able to go to my application.properties, and you can see I still have these properties showing in here, but they're commented out. So I don't need these properties because the application is not going to use them from here. It's going to call the config service in order to grab those. So this is what the previous application.properties file looked like, with just the actual values and uncommented, of course. But now we're able to let the app call config service for those. Okay. And then I don't need to change anything in the application. That looks good. However, we're going to be packaging these up as Docker containers. So I do also have a Docker file that I'm going to copy and put in the project folders for both the backend and the front end. And I will showcase that here. Where did it go? It's not showing. 1 second. It shows that it's in there. Oh, there it is, Docker file. Okay, so I have a base image that I'm specifying. It's just pulling a Zool version of Java version 17. This is kind of so people know who to contact if they have issues with the Docker file. So basically the maintainer, and then some. It's going to copy the backend.jar file that we'll build in just a second, and then run the java.jar or the java-jar, excuse me, with the backend jar file that we're going to build. So this is all that Docker container is doing, or the Docker file is doing. It's going to build a container with these specs in it for our backend application. Okay, so that looks good. Let's switch over to our front end application and basically do something very similar. Now, again, we don't need config service on the front end because it's not going to use database credentials at all. It doesn't care what's going on in the background. So we don't actually need to add anything to the POM. We don't need to change anything in the application.properties. However, you will notice here that it calls localhost port 8081. That works great when you're running locally or everything's on the same machine or so on. But what if you're running in Docker containers and they're on various servers somewhere, or you're running in the cloud? That localhost is not going to work, right? So ideally, you would have something like Service Discovery, something like Spring Eureka, or something else that would handle discovering where services are located and pinging those. But as kind of a workaround, because I have a blog post that talks entirely about Service Discovery, but we don't have time to go into that now. So it's kind of a workaround for that. You can use, oops, that was the wrong annotation, not the Lombok. I want the Spring value annotation. Is you can use the @value annotation in Spring and specify that, okay, when you see a backend.hostname value configured, so basically as a system property, use whatever's in that backend.hostname value. Otherwise, use localhost. And we're going to put this in a string hostname variable. So again, not an ideal, probably safest type of solution, but it's going to work for what we have for now. So, and then we're just going to plug that into, so whatever this value happens to be, it will just plug that into the URI and we'll be able to use that. So I'll showcase kind of the front end side of that, the other side in just a second. Hopefully it'll make a little bit more sense. But that's wired in and looking good. And then the Docker file, that's the only other thing. So again, same version of Azul Java 17, and we don't want to call this backend. We want to call this frontend.jar. So I copied the same Docker file into both projects, and that's why I have to update this. Okay, so that should be good. That all looks good now. Let's switch over. And I need to load terminal. Actually, there we go. And then terminal, bring this across so everybody can see this. And if I go to downloads, and then I call this Starof demo, and then I can go to my backend folder, and now I can do a Maven clean package. Now, because I specified config service, what the Spring app will do is when it does a Maven clean package, it's going to run tests. And because I have config service in the class path or in the POM, then it's going to run tests for config service, and it's going to be looking for a config server up and running, which I don't have one running locally here. So what I'm going to do is I'm just going to skip tests for now. Ideally, in a real production environment or a healthy, kind of safe environment, you would write tests to have a config service spun up and run all those tests and so on. But just for time's sake, we're not going to do that today. So we skip the tests for now, so that it, because it will fail the build. It looks for those tests. It's going to try to run them. It doesn't find a config service. It's going to fail them and it's going to fail the build. So we just went ahead and skipped tests for now. Now I can go over to my front end service, basically do the same thing. But again, since we're not using config service here, I can run all the tests in this app without failing any builds. So I'll go ahead and do that. And you'll see tests there. It starts running tests and so on. So it takes a couple extra seconds to run this build than it did for the back end. Okay. Now what that basically does is, let's see, I'll just showcase this really quickly. If I go into my target folder for each of these applications, you'll see there's a jar file that gets built. So that's what it's going to grab and populate in that Docker container we specified in the Docker file. And it's going to grab that jar and dump it into a container for us. So now if we go back out, I can look, everything should be in good order. So I should be able to do a Docker compose up -d. Oh, I want to showcase first, before I get too far ahead, the Docker compose. So I have this Docker compose file already spun up and written for you, because who really wants to see me write YAML, right? So this is already up and running, but I will at least walk through the code so everybody can see what's going on here. I don't know why it's not letting me resize the way I want to. Here. There we go. Okay. So we have our Docker Compose version, and then we have the list of services that we're going to use in this Docker Compose file. We have a config service, and here's our container name. So we can reference the container by this name rather than by IP address or something else, which I'll talk about more in a second. It's going to be using a Docker Hub image that I have, basically a template that I already have on my Docker Hub. So it's going to use the image that's based there. The default for the config service is 8888 for the port. So it's going to map internal and external ports here. I've got a couple of environment set up, Spring profiles, if you will. So this is really helpful if you're running like a test environment or a development environment or a production environment. You might have different credentials or different access or different properties even in different environments. So you can set up different profiles based on where you might be running. I've mapped a couple of volumes here. So one, to map a config directory so that it can find the config files to use in order to grab those credentials and provide them to whatever service might be calling them. And then I'm mapping log files. So in case something would go wrong, I've dumped the log files out to a local directory so I can see them. Then here's where the network stuff comes into play. So if I don't specify a network, Docker Compose will create a default network for me, which is great. However, the default network is going to only allow communication between containers using IP address, which is super difficult for me to keep track of which IP address is running which container. And of course, if you have different IP addresses that cycle or change over time, that's going to be hard to keep track of them. So what you can do is specify a custom network and then put your containers on that custom network. And then you can use the container name in order to reference other containers that they want to talk to. So that's super helpful, much easier to do. So that's what I've done here. I've specified a custom network that I want these containers to be on. There's our backend service. So again, the container name that we can use for reference, it's going to build the Docker container from a local file folder from the application we just built. So instead of using a preset Docker file that's out on Docker Hub or an application that's already out on Docker Hub, I'm going to build this live for you with what we just coded. So it's going to build from a local folder. Port mapping, again, we specified for our backend service using 8081. So that's what's doing there. It's going to depend on the config service. So if config service is not up and running, this service is not going to be able to go out and access the database, right? Because config service provides it the database credentials in order to work. So if config service isn't up, this service really isn't going to work. So it's going to depend on that config. I explained more about this in a blog post, but I had some trouble, especially with config service and other applications talking to it. If config service didn't spin up fast enough, then the front, this backend application would try to ping it, open a connection to it, and you can build resiliency and kind of retries into your applications. But for some strange reason, it wasn't kind of closing the connection and reinitiating the connection. So it was still kind of keeping that main connection open and wasn't actually, it would retry it, but it wasn't refreshing it enough. And so the only way I found to kind of resolve that is actually to restart the application or the container itself, and then it would reinitiate that connection to config service, and then all of a sudden everything was happy. So I've got some combination stuff. I talked more about that in the blog, but this is what I ended up needing to do there. I have a couple of environment variables, so it needs to know where to go out to which config file to grab for this service. It needs to know where to find the config server. And notice that I'm calling config server by name instead of IP address because I have that custom network. And then I want to use the Docker profile. So whatever's in that config service credentials for the Docker profile is what it's going to grab. So I could have different things for development and so on. And then again, that custom network. Same thing for front end container. It's going to look really, really similar, just different port. It's going to depend on that backend service, because obviously if the backend service isn't going to provide or can't provide data to it, then the front end service isn't really going to do any good. So we've put a dependency there. Same restart. And then here's that backend host name environment variable that I set. If you remember right, it wouldn't be able to find localhost running in Docker. So I've set a backend.hostname variable or environment variable for the container itself and say, look for backend, which is going to reference this backend container name, by the way. If I were using IP address, I could specify the IP address of the container, but it's going to look for backend and then port 8081. So it's going to look for this container in order to grab that data. And then of course the custom network. And then there's basically the definition for that custom network. Okay. So enough about that. Let's charge on over to our terminal and run this. So Docker Compose, going to spin up, and then it's going to do a -- build because I'm building the containers each time I run this. So because I'm using local file folders, not pulling straight from Docker Hub, I want to build in case I would make changes to my application locally and so on. I want to make sure I build those Docker containers fresh every time. So it's going to take a couple extra seconds in order to spin all that up because again, it's building those Docker containers on the fly. So it'll take a few seconds, but once that's done, then we should see that didn't take very long at all. Our entire system spun up, and now we should be able to go over to our browser and call port 8081/neo. Should, again, same endpoints. We didn't change anything within the application. So you can see we're getting our reviews. So everything's running in Docker. So that's the difference here. We haven't changed anything in the application itself, but now we've packaged it up, tossed it into Docker containers, and made Docker Compose orchestrate it and talk to it, these containers through it. Now we can do the same thing here. So just basically rerun this. And you can see we get the same reviews coming back there. So again, haven't changed anything. Everything's running inside an orchestration service. Docker Compose is handling all the connection and the communication details between that. We're just kind of enjoying the things that it's providing for us. Okay.
Hello. Hello, Ashwini. Hello.
Hello, sorry about that. My computer all of a sudden locked and went black, and that was the end of it. So
That's
let
okay.
me just
No
pop
problem.
back over to my slides
Yeah.
and wrap up. That was the only thing that was left, really. So, okay, share my screen again. Okay, there we go. So I just made you wait a few extra minutes for the resources at the end. So I was not doing that intentionally, I promise. My computer just decided to glitch up. Okay, so today's code, everything that we wrote is in that first repository link there at the top. This covers a wide variety of different topics. I go into more detail about Docker Compose. I go into topics on service discovery. I'm working on kind of wrapping this up with some Kafka and things. So anything that gets published for this microservices project is going to be published at that second GitHub repository there, link. So if you're interested in what I do in the future with this project and everything that I've covered in the past, feel free to check that out. I also go into a lot more detail about this through blog posts. So I dive deep really on some of the things I had trouble with or things I came across and why I made certain decisions and so on. So if you're interested in all of that kind of background, all of that's available on my blog. There's also a few kind of posted to external publishers as well. But everything is cataloged in my blog there at the third link. And then finally, I mentioned that Neo4j, AuraDB, our free tier instance, that's a cloud database, is available for anyone to sign up for a free instance. So you can do that at that last link, and you can spin up and import your own data, or we have some kind of preset data sets that you can use and have nice guides and walkthroughs that show you how to look at the data and review it and what it looks like and how to use it and so on. So again, if you have any questions, I'm happy to stick around for just a few minutes and chat and answer what I can here. But if you think of something later down the line, don't hesitate to reach out to me at any of those methods there listed in the lower left hand of the slide. Thank you guys so much for joining and hope to talk to you here soon.
Hey, thanks a lot, Jennifer. That was a brilliant session. And like we always say, most people who are trying to get into microservices, especially those transitioning from a legacy, monolithic application development background, struggle to kind of get their heads around the microservices thinking process. It's much like the object-oriented thinking process. It's a microservices-based thinking process. But no, I mean, this session sort of broke that down and then showed us, how we could do this, in a manner that is easy, and also, the whole thing around being able to use Neo4j, right? So that's also new because traditionally people are used to still working with uh, either the relational database or something like a MongoDB. But yeah, I mean with Neo4j, I mean we could see that there's a lot more power there. So thanks a lot for putting this together, really.
Absolutely. Thank you. And I do actually my full microservices project, because typically microservices aren't going to be dealing with one type of database, right? You're going to be dealing with lots of different type of databases. You'll typically have a polyglot environment. And so my full levels of this entire repository actually does have MongoDB as well as Neo4j running. And you're utilizing basically both strengths or the strengths of both different types of databases together in order to work with different types of data. So I have like books and authors loaded into Mongo, and then I have the reviews with the relationships between books and authors loaded into Neo4j so that you can really access the graph portion of the database in Neo4j and utilize that power. So again, all different databases are going to have different strengths, and you're not going to be dealing with one type of database, especially in a microservices environment, typically. So having access to all of those is really what I wanted to showcase. We just didn't have enough time to cover all of that today. So that's why I just went with Neo.
Right. Yeah. So and we have, a question on the chat. Are there microservices which involve the UI tech stack, such as Angular, React? So I mean, this is slightly outside, properly speaking, the topic of the session, but yeah, I mean, if you could answer that.
So UI, yeah, I mean, you could build an Angular or React app on top of the front end service to provide a nice UI to the user. So I'm not a specialist in UI or front end stuff, and that's why I didn't go into that. And also just for time's sake, but you could absolutely build a nice React app. So if you're thinking about building something like a Goodreads website where people can go on and record all the books they've read or the books they want to read, write reviews for the things that they know they like or dislike, and so on. You could absolutely build a nice application on the front end to do that. And then users could interact with the data through that app. And then your API layers, your backend service, basically, that we wrote today, would provide that data up to that application. So you can absolutely do that. It's just I wasn't able to do that in today's session. So
Absolutely. Okay. So no problem at all. But thanks a lot, Jennifer, for doing this with us today. A really
yeah,
interesting topic and a really interesting presentation. And we hope to bring you back again sooner this time for another edition of the Starof webinar.
thank you for having me.
Yeah. Thanks. Have a good day ahead. Bye.
Bye.